Hi everyone. So today we're going to talk about the number of solutions for a system, no matter whether we're solving by graphing, elimination, or substitution. You may have noticed in our last quiz, the second question, something was a little bit off with it. And this lesson will help you to understand the way you should have answered. So for the number of solutions of a system, graphically, we can easily see what's going on, but our overall intent today is going to be able to figure out algebraically what types of statements will lead us to these conclusions. There's three different scenarios that we may have. The first is if I have two lines, let's say that my first line is, oh, I'm a little bit ahead of my notes here. It's possible that these two lines might be parallel. So let's say that my first line is y equals 2/3 x minus 4. It's this green line right here. And my second line, parallel, same slope, we're going to make y equals 2/3 x plus 2. So very clearly we draw these two lines. They both have a slope of up 2/3. They're never going to intersect each other. Therefore, they have no solution. They never cross. They can't have a value which actually works in both lines. So we say this is either zero solutions or no solutions. Second possibility, which is the most common type that we've worked on over the past couple of weeks, is when we have one intersection. The two lines clearly cross one another, and the coordinates of that dot are where we have our solution. Let's suppose we have y equals 2x plus 1 as our first graph, y equals negative 1/3 x as our second graph. We can see when we draw this, they don't intersect at an overly nice position, so we're just going to kind of guesstimate our answer. We could find a better fraction if we did it using substitution or elimination. But we'll say here it appears that our answer is going to be at about negative 0.5, comma, positive 0.2. Again, one solution. Our third type is if I've got two equations which, even though they look different as equations, represent the exact same line. We call these coincident equations or coincident lines. They coincide with one another. An example could be y equals 2x minus 3, which is this green line. And my second equation looks different, 4x minus 2y minus 6 equals 0. But when I go about drawing the graph, I'll notice that whether I use my xy intercept method that I'm showing here, or if I were to rearrange the equation, I end up with a line which is sitting right on top of the other line. These two lines touch each other at every single point. So we say that they have actually infinite solutions. Algebraically, three different things can happen, and we just need to be able to interpret what these things mean as far as whether I'm getting one of these special cases or not. So we usually find this after the very first solution for the first variable. We don't have to plug back in to keep going to understand what's happening. So if I've got something which I'd call a regular solution, it will produce x equals a number or y equals a number, as we've seen over the past few weeks. So my first example, suppose my two equations are 3x minus 2y equals 7, and 2x plus 2y is equal to 7 as well. If I was to go about solving, I added them, I'd get x equals 0. That's a number. I know right away I'm going to have just one intersection, one solution. My parallel lines will be produced by a false statement, something which is impossible. So my example here, first equation, y equals 2x minus 4. Second equation, 4x minus 2y plus 3 is equal to 0. Here I'm using the method of substitution to solve. And when I do, I'll notice that my x's cancel out, and I end up with 11 is equal to 0. No, that's not possible. I therefore know that these are actually parallel lines. I just say 0 solutions. Infinite solutions come from a true statement. Again, there will not be an x equals, there will not be a y equals, there will just be some number is equal to itself. So in this example, I'm setting it up. Once again, I'm going to use the substitution method. I solve, my x's cancel out again, but this time I get 0 equals 0. That is true. That tells me these are coincident equations, which tells me that there are infinite solutions. That should be enough to give you a really good idea as to how to go about this homework. It's on page 448, just to give you a few practice questions. Enjoy it, and I'll see you sometime during the week. Bye for now.